Yes, we want to continue our lectures on what? Inequality. In today's class, we have a very simple problem here to solve. I say find the solution set of the absolute value of 3x minus 2 less than 4 and present the solution on a number line. So look at the question, absolute value of 3x minus 2 less than 4. So we're going to solve this in two ways. The first is the positive side of it, right? So it's going to be like 3x minus 2 less than 4. We solve it, and we're going to solve something like this, 3x minus 2 less than 4. That is why we're going to have two sets of solutions, that is two answers. Now, look at it. 3x minus 2 less than 4 is going to be what? 3x less than 4. We carry this minus 2 from the left to the right. It changes to what? Positive. So 3x less than 4 plus 2 is 6. All right. What are we going to do now? We divide both sides by 3 because our target is to make this s the subject of the formula. Now, s now less than 6 all over 3. So the answer is s is less than what? 2. Then the second one is this, the negative side of it. So minus times 3s, we have minus 3s. So minus times minus 2, we have plus 2 less than 4. And what are we going to do? We need to carry plus 2 to go and meet 4 at the right hand side. And as this plus 2 is crossing this inequality sign, it changes to what? Negative. So we now have minus 3x less than 4 minus 2 minus 3s less than what? 2. Now, what are we going to do? We multiply both sides by minus so that this minus has to leave this side. So we now have 3x greater than what? Minus 2. Why did I change the sign? Whenever we are multiplying, what's it called? Why did I change the inequality sign? You know, before it was less than, now we say greater. Whenever we are multiplying or dividing, what's it called? An expression by negative sign, maybe negative 1, or we are multiplying by negative 1, the inequality sign will have to change. That is why we have 3x greater than minus 2. Now, x now becomes what? Minus 2 all over 3. Now, if you look at it very well, that's why they say find the solution set. So there are two answers. So, and the final decision is to present this on a number line. Look at this. Let us assume that this is my 0 x. Here is the positive side of s and this is negative side of s. So since s is the same minus 2 over 3, so let's pick here to be, but mind you, this is not drawn to scale. We're not going to draw it to any scale. We just assume that this is minus 2 over 3 and this is 2. So this one, they say s is less than 2. When you are going to the right, it means x is more than 2. Because this is 2, 0, it means 1 should be somewhere here, 3 should be here. So we raise this thing up. We can't go this way. We come like this, all right? But mind you, here is going to be, it's not going to be shaded. And even this is less than or equal to, that is when we would have shaded this portion. Now it's not shaded, just a ring. Now, the other one, x is greater than minus 2 over 3. When you go a little further to the left, you are going to, as in, no, this one may say s is more than. So for s to be more than, we go this side because 0 is more than minus 2 over 3. But when you go to the right, you are saying x is less than minus 2 over 3. So is now, we take this here. Remember, mind you, this is not shaded. We go this side. Because going this side, it means what? X is less than 3. Because all the numbers here are automatically less than this. Because minus 100 is less than minus 1. Even minus 1 million is less than what? Minus 1. So going this side, we are talking about less than minus 2. But when we go to the right, it means greater. So you can decide to join these two. So this is the number line representation of our solution. Bye.